Hi, I'm an old guy and I do maths, and today I want to look at the idea of independent events and the probabilities around them. So, what is an independent event? It's an event that is not influenced by something prior to it. An example might be the throw of a coin. If you throw a coin once, you get a head or a tail. If you throw it again, you get a head or a tail, and the result does not depend on the first throw. Now, there are a number of formulas circling around when it comes to probability, and strangely enough, the first one we're going to look at doesn't involve, in theory, independent events. It involves the dependence of one event upon another. And that's this little notation here. But if an event is independent, it doesn't depend upon the occurrence of another event. So the probability that event A happens given that event B happens is simply the probability of A if the event is independent. So the throwing of a coin and the getting of a tail does not depend upon a previous throw where you got a head. That's really what we're talking about here. So this notation has to do with probabilities that depend on each other. You'll notice that we have A in here and that B simply disappears when we talk about an independent event. We'll get to why that is in a moment. Now, the probability of A intersection B, if A and B are independent events, simply is the probability of A times the probability of B, which can be illustrated quite quickly here with a little tree diagram for throwing a coin. So this is the first throw here, and these are the second throws. So if you throw a tail, you've still got an equal chance the next time of throwing a head or a tail, and similarly for that. And so when you work out the probability of A intersection B, it is the probability of this times the probability of this, because these events are independent. So this is another test of independence. So if this equals this, your events are independent. If this equals this, your events are independent. Now, taking this first point here, how do we get to the point where this would equal this? Right. Well, there's a little bit of a story here. So the probability of A given B is equal to the probability of A intersection B over the probability of B. You've probably seen, no pun intended, you've most likely seen this formula, shall we say. Now, the fact is that this, if events are independent, is equal to this. The probability of A times the probability of B, and if that's placed over the probability of B, we're looking at this. But note, we can cancel, because that divided by that will give us 1. And we're left with that, the probability of A. So we've gone round in a big circle to some extent. The probability of A given B, if the events are independent, is equal to the probability of A. And this is why. Okay, I hope that made some sense, and I hope it cleared up some of the mystery surrounding why at one moment you appear to be dealing with this form of probability, and suddenly everything comes down to one item. Anyway, the key takeaway: independent events are events that are uninfluenced by any external factor other than their own occurrence. Thanks very much for watching. I hope you found that useful. If you did, please like and subscribe, and I'll see you next time. Bye.